In this video, we're going to solve this particular problem using breadth first search. So we can see there is an initial state S and a goal state G. So how do we go from initial state to goal state using this particular algorithm? First of all, we'll start with a list of visited node. Initially, the list of visited node is empty, and then we'll maintain a queue. And then in the queue, we first add the element S. Now, since we need to visit this particular node, what we're going to do is we're going to visit this node here. So in visited node, we have S, and in the queue, since S is dequeued, now there are two extra nodes that come into play: the node A, the node B, and node C, which are all connected to the S. So now in the third step, we first visit node A, which is the first element in the queue. Then once we visit this node, in our visited node we get S and A. Now since node A is also connected to node D, now B moves to A's place, C moves to B's place, and then D comes at the end of the queue. Now since B's turn is next, in the visited node we have S, A, and B. After that, since we've also visited B, our queue is updated and we have an extra element in our queue, which is E. The element D and C are there as it is. Now we visit the element C. So in visited node we have S, A, B, C, and in the queue, since the element C is dequeued, we now have a new element in our queue at the end of the queue, F. The other element E and D are there as it is. Next, we dequeue this particular element D, so S, A, B, C, D, and then we have our queue updated as there are new node G, and F and E are already present in the queue. Now we dequeue E, we visit E, S, A, B, C, D. Since G is also connected to E, we try to place it in the queue, but we already have G in the queue, so we don't need to add G repeatedly here. Now the elements remaining in the queue are G and F. Now we also visit S, A, B, C, D, and then we visit E and F. I forgot to mention E here. E and F, and then in our queue we only have an element G that is left to be dequeued. So finally we visit the node S, A, B, C, D, E, F, and G, and there are no more elements in the node. And since we have started from initial point to final point on the goal state, this is the path that is given by this particular approach here. So this is how we solve this particular problem using breadth first search.